A 99% of museum visitors miss this hidden science. The art of preservation begins long before display. Every artifact holds a precise, documented history. And now that we understand the archive, let's explore assembly. A skeletal assembly is a massive three-dimensional jigsaw puzzle. An accuracy requires micron-level measurements for correct orientation. The challenge is identifying orientation in chaotic deposition. The reconstruction often demands educated inference from incomplete data. A modern adhesives must be reversible, durable, yet non-invasive. This bonding agent must withstand decades of environmental stress. Unassembling large skeletons requires custom support armatures. These supports mimic internal bone structure for realism. And achieving correct posture is crucial for anatomical integrity. The connection must appear organic, hiding the underlying engineering. And now that we understand assembly, let's explore preservation science. The organic specimens face constant, relentless chemical attack. By environmental stability is the primary defense against decay. Fluctuations of even a few degrees can accelerate deterioration. But to textiles, paper, and organic materials require specialized gaseous environments. Inert gases displace oxygen, halting oxidation and biological activity. This inert atmosphere buys us centuries of necessary observation time. For hard specimens, chemical consolidation is often employed. A weakened fossil matrix is infiltrated with stabilizing polymers. The X-rays reveal how deeply the consolidant penetrates the structure. But this process restores structural integrity without adding bulk. Curators must be experts in geology, chemistry, and history. But the completed mount must tell a compelling, accurate story. But each bone placement reflects years of rigorous scientific consensus. Or color matching, or painting, bridges the gaps between missing elements. The goal is seamless integration, not deceptive mimicry. This represents thousands of hours of careful, quiet dedication. Now that we understand the visible display, let's examine display technology. Illumination must be powerful yet entirely UV-free to prevent fading. Digital displays offer layers of context inaccessible physically. High-resolution 3D models allow manipulation of digital twins. Security systems employ invisible barriers to guard priceless assets. Subtle physical changes trigger immediate lockdown protocols. These precautions ensure artifacts survive unexpected human error. Even cleaning requires specialized, non-abrasive methodology. The curator is the steward of deep time and material existence. Smaller specimens require immobilization using micropins and resins. The pin must pierce the chitin layer without shattering the body. A systematic arrangement aids comparative study across decades. But geological samples demand different stabilization techniques entirely. A petrified wood requires hardening agents to retain its cellular structure. Wet specimens rely on chemical baths to halt decomposition entirely. Maintaining fluid concentration prevents desiccation or structural collapse. These chemical matrices must be refreshed periodically over long cycles. Effective curation demands high levels of interdisciplinary collaboration. Creating the final display narrative requires sculptural artistry. The public only sees the final, seemingly effortless presentation. But this clarity is built on layers of chemical and physical intervention. When every object needs an accessible, yet secure, digital footprint. Tool selection is as critical as the conservation chemicals used. The removal of matrix must be painstaking, slow, and patient. The final product stands as a monument to conservation science. It bridges the vast gulf between discovery and public understanding. But preservation is not stopping time, but managing its effects carefully. These curated mechanics allow knowledge to endure beyond the original lifespan. This dedication transforms fragile remnants into permanent, powerful truths.